You're good. Go ahead.
Cool. Well, thank you everybody for having us in today. We're going to just kind of take this a little bit differently. Some of you have probably heard us talk about fabric a little bit before. And today what we're going to do is kind of start with a broad understanding, kind of a broad look, and then bring it in. And Corey is going to come in towards the end. She's got a kind of a cool project that we wanted to give you some specifics on and kind of show you how all of the details of this work out and how we can incorporate that into projects working for you guys when you are designing systems with fabric. So we'll start off just by taking a look at some of the basic fabric user characteristics. And these are things that exist pretty much with every manufacturer. Will have some version of this. And I'll point out a little bit of that as we go through so you know what's general and what's specific to certain manufacturers. Everybody is doing their systems with engineered polyester fabrics, and not polyester fabrics like Uncle Tom's spacesuit here. It's going to be actual engineered polyester fabrics. And the reason they do that is because these fabrics they don't rust. They don't have any kind of corrosion issues whatsoever. There's no retention of moisture, and they're very antimicrobial. So you've got almost inherently clean types of materials that we're using with these. And again, this is kind of applicable to all fabric duct manufacturers. They're all using engineered polyester for most applications. The way these are made is a system that's called that we're doing to specifically eliminate a lot of the roughness and the tough finishes that the fabrics are made out of. So that what you're going to end up with is fabrics that are rated for use in clean rooms down to ISO 4 cleanliness standards. So a lot of really simple stuff that happens with the fabric that a lot of people don't necessarily think about. This was a specific question that was brought up that actually Tracy pointed out to me when we were setting up, was about fire resistance. And that's just be really clear that all of our products, and frankly, all of the big products that you would encounter with other manufacturers, are going to be ULC classified systems. There are two different UL listings. There's UL 723, which is kind of a general anti-burn, anti-fire type UL listing, and 2518, which was designed specifically around textile air dispersion systems. So it's looking at not only the fire and the smoke resistance, but also looking at overpressurization and total wear and tear on these systems as well. All the systems are very hygienic. And this is going to be pretty generic across all manufacturers. And one of the big reasons I'm pointing out all of this is that as you guys are working, I'm sure you're seeing the prices for metal just going up and up and up and up. What we're going to talk about, and Corey's got a couple of good examples later, is specifically how less expensive fabric can be, not only in terms of installing it, but with this hygienic design, we're able to be really easy maintenance as well. So these are all easily launderable. You can do this with just washing in commercial laundry systems and using basically what amounts to an industrial version of OxyClean to maintain the cleanliness and the hygienic status of the system. So it's really, really simple, quick, easy maintenance for these. It's also a very sustainable product. This is one that gets, sustainability is becoming more and more of an issue with more and more customers. And fabric opens itself up in a lot of different ways. Different manufacturers will have different levels of sustainability. What we do is our Prihoda Recycled is 100% post-consumer recycled material. So everything, it's basically old water bottles that have been converted into polyester fabrics, and then we have had manufactured into fabric systems. So you're completely recyclable. It is also ULC listed. So this is the only fabric that's 100% recyclable that's carrying that. And if you're doing work in LEED, or what we've been seeing more and more is the Living Building Challenge, these types of products allow them to just fit in really, really well. Version 4 of LEED expanded the credits that were available to bring in passive equipment like fabric ductwork. And the Living Building Challenge has a list of ingredients that have to be avoided. We've been approved for the red list avoidance on Living Building Challenge jobs as well. So that's another aspect of fabric that is typically overlooked, but something that can be really important depending on the type of projects that you're working in. In terms of aesthetics, this is one of the biggest benefits, in my personal opinion, to fabric is the custom aesthetics capabilities. Starting with shapes, everybody is familiar with round fabric ducts. This is one that pretty much everybody has seen, but the shapes that are available start to expand really quickly. So we can take that down to a half round size. These can be surface mounted, they can be suspension mounted. You can get a lot of different options available with the half round, including what we call an ellipse. This is basically a half round that changes the aspect ratio. So it spreads out at the top and shortens the distance between the ceiling and the room. So when you've got, like in this application here, a small office ceiling that's low, we can incorporate the ellipse design to provide that comfortable airflow down to these spaces without just blasting folks that are working in these different cubicles or different spaces. Quarter round, this is my personal favorite shape. I love quarter round jobs when we get on those. This is one that we did. This is a small little arts, kind of an artsy movie studio. And what we did here was incorporate the quarter round, which is going to mount where the ceiling and the wall come together up in that corner. Those are on both sides, providing airflow, along with a half round that's mounted, surface mounted to the ceiling. These were done in the black color so that they would blend in. This is, again, another thing that fabric in general, but specifically the Prihoda fabrics, allow for, is this kind of customization on the aesthetics. So you can make them blend in or stand out depending on the type of space. Another really cool fabric design, and this is one that Corey's going to talk about a little bit because she specifically used it on the job we're going to talk about, is the rectangular design. This is relatively unique to Prihoda, and the way this is set up, we can do these as both positive supply line, like what you see in this picture, or the rectangular systems can be set up for a negative, so they can be the return in the space. We've done a number of swimming pools where we've incorporated these rectangular systems, pulling negative pressure to exhaust airflow out away from the pools to keep those spaces clean and very comfortable in the space. Colors and patterns, this is something, again, most people have seen a lot of this. Fabric ducts are typically available in a lot of different colors. We stock 9 standard colors, which you see here. But the coolest thing that we can do is what we call Prihoda art. This is a completely custom printing system that allows basically high resolution digital printing of any design onto the fabric. So any color, any logo, any patterns that you want, including this one on here on the left this is a beer. This is weed. This is a really cool printed graphic design, and this is actually a customer's logo. So a lot of different ways that we can incorporate that Prihoda art to provide you guys with really, really cool aesthetics. It's also one of my favorite things about the Prihoda systems. In terms of actual function, this is where the details start to come in from just these great ideas into kind of more specifics. And what we're talking about with fabric systems, almost all of them are going to be designed looking at throw distance. So how far does the air need to be moved, and what type of air distribution methods are available for that can be incorporated. Those short design systems that I mentioned before, so low ceiling offices, classrooms, that kind of situation, we're going to be looking at what we call micro perforation. This is a patented design that we came up with. These are all very tiny laser cut perforations What the patent is about is the way that they can be put in. The diameter of these is smaller than the thickness of the fabric, which means that the edges can be beveled. So they can be adjusted and provide directional control for the airflow. What you end up with is a system like this. So rather than typical permeable systems where the air just drops directly down, it's going to move out and away from the diffuser. So you get more efficient air distribution with more comfort. So we can get a larger volume of air with a lot more comfort into a space rather than like this, where we're just the air would just be dropping down. So you get a very efficient, very comfortable air distribution using the directional microperforation. Typically, what you're going to be seeing, and this is where most people are going to be incorporating fabric, will be higher ceiling applications with longer throw distances. Typically, what we're running in is like a 10, 20, sometimes maybe a 30-foot throw distance. And in that case, where we move, and this is, again, this is kind of a generic thing for all manufacturers, is into standard perforations. So these are going to also be laser cut. They're going to start at about 4 millimeters in diameter and go up from there, depending on the volume of air and the actual direction and distance that we need to be able to move it. These can also be located in any position around the diffuser, so we can be very precise about the direction of the airflow and control that very, very easily by locating these perforations. And one of the interesting things about perforations and the way they operate in the system is the way air moves out of them. So if you've got a system that's installed, and this is actually a really good picture that shows that, from left to right here, this would be our inlet for this system, and the air would be moving in and moving this direction. Typically with the perforations, that's going to deflect. So air is going to move in that general direction as it moves out of the perforations. And what you end up with is spots underneath the inlet where you're not effectively ventilating that space. You're not getting air moving in there. And so it's kind of a dead zone. By using these textile air control pockets, we can direct that airflow and move it back to straighten that out. So we'll put it in at the end of each little section of the perforations and straighten that airflow to eliminate those zones where we're not getting any ventilation. The other really cool thing, and this is another benefit of fabric in general versus metal, is the capabilities we've got for designing custom airflows. This is an internal or an indoor swimming pool, indoor pool facility up in Minnesota. And as you can see here on the left, this is a floor to ceiling wall where we had to use nozzles to be able to move a lot of air out and prevent condensation, because Minnesota winters and indoor swimming pools don't really go well together. But the architect had also designed into this these yellow ceiling panels. These are just purely a vision thing. These are not functional. They don't supply any air into this, but we needed to move air underneath them to keep this ventilated down here. Those perforations, those textile air control pockets have been turned and lined up with this ceiling panel so that the air is moving underneath there and moving around here. Again, something that would be almost, if not completely, impossible to try to accomplish using a typical metal distribution system. The fabric really lends itself well to those type of installations. When we move into applications more like a lot of indoor manufacturing will be these longer throw distances, starting to move out 50 feet or so. We're going to move to nozzles. And the way Prihoda does nozzles is a little bit different than everybody else. All the other manufacturers incorporate plastic nozzles to these. A couple things there. One, plastic, the colors don't match, so it's not going to look exactly the same. The second problem there is the plastic is not fire resistant. So when you've got rows and rows of plastic nozzles, you're actually adding a lot of burnable material into these designs. By using the fabric that we build the diffusers out of to make our nozzles, we eliminate both of those problems. It's going to maintain the fire resistance and maintain the overall system aesthetics and color matching. These are going to be available in different diameters, depending on exactly the volume of air that we're working with and the distance that we need to move it. But you're going to get throw distances, very direct throw distances, up to about 45 to 50 feet, depending on what the static pressure actually is in the system. Real quickly on these, a couple of different ways that we do these. For places where the aesthetics are not that big of a concern, industrial manufacturing being a great one of those, we'll use a single wall design for these, single wall constructed nozzle. For places where the aesthetics are important, we use a double wall construction with a little metal wire that goes around the opening to maintain that shape. The purpose of that is to eliminate any vibration from these small nozzles. It's just a very small but very customized aesthetic improvement to the systems when we start moving nozzles there. Then there are those jobs where the air really needs to be moved a long distance. We're talking out 80, 100 feet. This is when we move into a slightly different design nozzle, but again, something that's really easy to accomplish. These are also manufactured from the same fabric material, same polyester that the diffuser itself is, but these are stitched on rather than being an ultrasonic connection. Those smaller nozzles that I showed you, those are ultrasonically welded to the diffuser. These are going to be a little bit stitched on, but these are going to incorporate small dampers, manual dampers that could actually be used to completely shut off the airflow from each of the nozzles if necessary. And we've done a number of industrial manufacturing installations with these doing that, where they all have the small things inside to allow the users to turn the air on and off as they need to, depending on what's required for a given application. This can be fixed, or we can actually put these in as field adjustable. This is another one that gets used a fair amount in those type of industrial manufacturing applications that I was mentioning. The one thing that we always talk about with fabric, and this is something that all of you have probably experienced at least some level of, is the concepts of suspension and hold open. Old school fabric systems were just fabric ducts that would collapse on themselves when the air was turned off. And then when the units were turned back on, they'd pop out and be really loud. Over the years, different methods of dealing with that have been developed. But the first one of those, frankly, being designed by Textile. You guys have probably seen the name Skelecore. They managed to tie that into a really cool old school TV show that I used to love to watch as a kid. But what they designed is actually it's actually a really good idea. These things are really cool. What they've got here is a series of internal rings that are connected by a tensioning rod, basically, that all of this is field assembled and installed in the diffusers as they're being installed on the job site. They work really well. I'm going to be just very frank about that, but they're also extremely expensive and require a lot of field work by the contractors. Most of the time, the contractors are not going to be happy having to incorporate these, despite the fact that they do a really good job at maintaining that tension and holding the system open. They're expensive, again, and difficult to install. The way we do that is a system that uses both the internal rings, but also a different way of providing tension. Instead of having a field assembled rod that fits in the middle there, what we'll do is use what we call a track tensioning system. So it's a very small threaded rod that fits into the end of our installation track. And this tab right here will fit down into a pocket that is installed on top of the diffuser. When that tightening bond is tightened, when that rod is tightened there, it's going to pull that tab back and tighten the entire fabric across the internal supports. So when we've got those internal rings, it'll pull the fabric tight across the top of those and maintain that overall shape. This is a picture of an installation that we've done using these. This picture was made with the air turned off. The units are turned off in this small gym. And it was really important to use these because the diffuser was going through the ceiling structure, and we couldn't allow for the fabric to just hang on that at all. So this has the internal rings providing the main support, and then the tensioning on the ends that are pulling it tight. Very, very inexpensive, very easy for the contractors to install, because basically all of this is set up at the factory. The rings are going to come in from the factory. The tensioning systems are just a couple of rods that are tied in and tightened down. Very, very simple, but very effective. This is actually a really cool way to deal with those hold open and tensioning questions. Now I'm going to turn this over and Corey do a little bit of talking about the specific job that she's worked on, and kind of dig a little deeper into the specifics of system design and what we have to take into account for those type of things. Corey, you got it?
I do. Oh no. Jeremy, can you click it back 2 slides? Okay, so I put together a brief case study on this project that we designed called the Jack Links Aquatic and Activity Center. So when our customer initially reached out to us about this project, it had went over budget, and our customer was open to any design changes that we saw necessary. In the initial design, we supplied this piece of duct here in the pool at a 52-inch inlet. They requested us to change that to a 40-inch diameter to be able to clear the windows on that exterior wall, but they also wanted the duct to rise at the inlet to be able to get above those windows. When we initially did this, we tried to do it in the round like they requested, with the smaller diameter and the offsets at the inlet. However, our inlet velocity increased to about 1,700 feet per minute. On average, we like to keep that inlet velocity between 1,000 and 1,500 feet per minute. In this case, decreasing the diameter and adding those elbows created a lot of vibration there. The vibration in this case wouldn't have just made the duct all flappy, it would have also caused sound issues there. So we looked into other options to be able to fix this, and we thought that our rectangular duct would work perfect here. So not only can we supply our rectangular duct in supply air, but we can also do it in return. So we were able to get the dimensions that they needed here, as well as not having to worry about the higher inlet velocities there, because our rectangular duct can actually hold up to velocities up to 2,000 feet per minute. And this is all because of the track that it is supported with. So all of this track has the in-track tensioning in it, and that allows the duct to be tensioned and be able to handle those higher velocities. So for the gym portion of this job, there's nothing really spectacular about the actual layout of the duct. However, we did have to focus on how high above the ducts were in this. This job is in Wisconsin, so we definitely have to worry about heating getting to the floor. And so we chose to use our small textile nozzles in this application that can throw up to 40 feet. We also on the gem supplied track and rings. The main reason for this is we did not want the ducts to deflate when the unit was off and hang over any of the piping in that. Also, we didn't want to have any startups popping noises. So the rings held the duct open and allowed it to go through the joist in there without touching anything, as well as the track provided that in-track tensioning to remove any creases or wrinkles that could be on the fabric from shipping. So this here is what we call our airflow chart. And all it is showing you is the feet per minute at a certain height and certain throw distances. So on that right-hand side of the screen, you can see a chart, and that is actually showing the speed that the air is traveling at, so our feet per minute there. The chart itself shows the air So on the left and the right of the chart, it shows you our height that the duct is going to be installed at, and at the bottom and top, it shows you the distances that the air is traveling from left and right. This was the final design for the gem, so it may be a little hard to see, but it is the white duct in all of the brace truss. So you can see the textile nozzles in there to make sure that we can get it to the floor. And this was the final product for the pool. So you can see on the right-hand side, we are clearing those windows as well as some piping that was in the way while being able to wash the windows with the air. In this application, we did do cable suspension, and all of our cable suspension comes coated stainless steel for pools, so we do not have to worry about any of the corrosive environment stuff breaking down and degrading our product throughout its life. And then the last thing I wanted to talk about is cost savings with fabric. So we can save anywhere from 25 to 75%. We've had a few jobs where we have had significant savings, and one of them was our Bluebell plant. So originally that was designed with a stainless steel supply and return ducts. We quoted them just our premium duct, which is just a permeable duct with an antimicrobial coating, since this would be in a food environment. And we provided it with our 360-degree rings as well as our track suspension that has the N-track in it. And we also supplied 7 return ducts on that job, and we saved them over $1 million. And then we also provided a job called BP Cherry Point Substation. On that one, we saved them about $14,000, give or take.
And that's something that we put in. That was kind of a last minute thought about the cost savings on those projects, because that's becoming more and more of a concern. I mean, everybody has had problems with metal pricing forever, but that has continued to go up, and we've been seeing our reps encountering jobs where the only real option from a financial standpoint was to shift over to fabric. And we can really offer a lot of that. That was a lot of what Corey was talking about there. That was a very customized job. There's a lot there because she had to take into account the structure, the piping that was through that space, a lot of different concerns there. But we can do all of that quick design work for you guys and provide that information back out. So we love to get involved at the beginning of projects. If you guys have questions or thoughts or new ways to maybe approach something, that's where fabric can start to really provide you a lot of benefit, because we can take the ideas, apply these type of systems, and you don't have to do a lot of that legwork on your own. And you can handle that design and handle that sizing for you. Tracy, I think that's about as far as we are officially set to go.
Okay.
We left some room for questions and further discussion, so I'm going to turn it over to you now.
Yeah, that's great. We have quite a few questions here. So first off, we'll start with the question and answer down at the bottom. If anybody else has any questions, please add them in there. On the negative pressure duct design, how does the fabric duct not collapse?
It has, Corey mentioned it briefly there, but what it is, it's a 4-track system. So the corners of each part of the rectangle, all 4 of those corners will be full length aluminum tracks, and then there are vertical support rods spaced about 1.5 meters or 2 meters between those support. Basically, we call them profiles, the rods that would go in. The horizontal part will stretch that out and pull the tension on the system from left to right, and then we'll get the tension with the vertical parts from top to bottom and prevent any collapse or any collapse on those systems at all.
Is there like a static pressure requirement, like a maximum, well, a minimum, I guess, a negative?
Oh, Corey, what's the most have you got a number that you've worked with on that? We haven't really done a whole lot of the negatives on these, but I can find that out for you.
Yeah, that's just me elaborating on there. So the next question, does air distribution take advantage of the Coanda effect?
Yes, absolutely. That's sort of the basic idea, is using the Coanda effect. And a really good example of that is that indoor swimming pool project that I showed the pictures of, with um, the control pockets turned 90 degrees. That's using the Coanda effect, moving that air across that ceiling panel that was designed in, so that we're getting further air distribution off of that system. And that's something that we use a lot, trying to move air around at the ceiling level. And using those micro perforations is another really good place where that can happen, expanding on the Coanda effect that we've got available there.
Okay. Can you talk about the pros and cons of Perhoda's fabric duct offerings in sound sensitive environments, such as recording studios, theaters, and performance venues?
That is a very excellent question. And we do a lot of sound sensitive applications. In fact, one of the biggest that we've done is right there in your backyard. The Doing some recording studio stuff. And so, yes, typically what we design for, like Corey was mentioning, in those more typical jobs, will be inlet velocities of 1,200, 1,300 feet per minute. One of the big things we'll do with sound sensitive is increase the diameter of the diffuser so that we reduce that inlet velocity and remove a lot of the sound that can come in. We can also provide fabric. Sorry, just completely lost my brain. Those, so yes, I'm
When
sorry.
there is a fabric duct sound silencer, correct?
Yes, there's definitely the fabric duct sound silencer, and the software itself is actually evaluating that. So we're looking at sound generation by each system as it's being created. So if we've got target NC levels, we can adjust that sizing and adjust the design to meet those NC levels, which is what we've done in countless indoor sound sensitive applications.
Okay, great. So one more here. Can you discuss the static pressure requirements for the duct? Inlet, external static needed, and how much static is lost per foot of duct?
I do not have a good answer on the how much is lost per foot of duct. That's a different, sort of a different approach that's not really tied to fabric that often. All of our design is sorry, I'm having a, Corey, can you jump in and answer that? Sorry.
Yeah. So we typically design at about a 1/2 inch, but we can go all the way up to about 3 inches of static pressure. Um, and of course, the amount of static pressure that we need will depend on how many elbows, offsets, or anything like that that the system has. But typically, a 1/2 inch will get us where we need to get in any system.
So a 1/2 inch at the inlet of where the fabric duct starts. Yeah,
Yes.
that's kind of the generic answer that we've been given out too.
Yeah.
It always depends, right? That's the answer. But I saw some stuff in there. We had a question about will the supports have issues in a natatorium environment?
Typically, we do not recommend to have any type of hold open in a pool because they do run 24/7. However, if they are needed, there should not be any issues in corrosion or anything like that.
Okay, I got one, and we already answered the static pressure, so that's about it. We can finish up right here. We just got one more. Do you offer insulated transfer ducts?
Yes, we can.
When you say transfer duct specifically, what are we talking about there for an application? We can do insulated versions of all of our diffusers. We would, depending on specifically what's being transferred, we probably need to look at a little more in detail, but transferring supply
transferring supply through an unserved space.
Yes, we could definitely provide insulated fabric for that. That would be, that would help to eliminate any problems with condensation depending on the temperature differentials. So it is possible. We don't do a lot of insulated systems, but it is definitely something that's pretty easily capable.
Okay, we'll, I think we're having some